Welcome to our scientific presentation on Conyza sumatrensis paper soap, an innovative hygiene product designed as a practical solution for preventing skin irritation and bacterial infection. This project was developed under the supervision of Dr. Dian Ayuningsih at the Department of Biology, Faculty of Science and Technology, Walisongo, Indonesia. We will explore the background of the global skin disease burden, the antibacterial potential of Conyza sumatrensis, the formulation step used to create paper soap, and the scientific results supporting its effectiveness. Our research team consists of Aulia, Sari, Putri, Dewi, Siti, Linatur, Rizqi, and Lulu, Zahrotun, Nisa. Each member played a key role in the development of this innovation. This study has two primary objectives. The first is to develop a practical and hygiene cleaning solution specially aimed at reducing the risk of skin infection caused by Staphylococcus aureus, a bacterium that commonly attacks the skin and has shown increased antibiotic resistance. Our second objective is to utilize the natural antibacterial compounds found in the leaves of Conyza sumatrensis. This wild plant is abundant in tropical regions and contains several phytochemicals that are scientifically known to possess antimicrobial properties. This slide summarizes the entire research process in a flow chart. We began by identifying the increasing prevalence of skin disease caused by Staphylococcus aureus, as well as the challenges posed by bacterial contamination in daily life. After establishing the problem, we performed an in-depth analysis of the need for a hygiene product that is both safe and practical, especially for individuals who frequently travel or have limited access to soap and clean water. Next, we examined the antibacterial potential of Conyza sumatrensis leaf through preliminary phytochemical references. Finally, we test the antibacterial activity of the formulated paper soap agent Staphylococcus aureus, allowing us to evaluate its effectiveness as a natural antibacterial agent. Skin disease remains one of the most common non-fatal health problems globally. According to the Global Burden of Disease Project, skin disorders are consistently ranked among the top contributors to disability worldwide. International initiatives, including those driven by the World Health Organization, emphasize the importance of improving hygiene practices as part of global health strategies. In this context, affordable and practical hygiene products such as paper soap become essential, especially for preventing early-stage skin infection before they develop into more severe complications. Global data from 2021 reported over 4.6 billion incident cases of skin and subcutaneous disease. This condition accounted for nearly 42 million disability-adjusted life years, placing them among the top causes of non-fatal health burden. A major contributor to this infection is Staphylococcus aureus, a pathogenic bacterium that frequently colonizes the skin. It is also one of the key species associated with serious complications, including antibiotic-resistant infections. Medicine-resistant Staphylococcus aureus is especially concerning, causing more than 100,000 deaths annually. This highlights the urgent need for preventive processes that do not rely solely on antibiotic treatment, but begin with improved hygiene practices. Conyza sumatrensis, commonly found growing weed in tropical regions, is often considered a weed with no economic value. However, recent studies have revealed that this plant is rich in secondary metabolites such as flavonoid, tannin, saponoid, glycoside, and triterpenoids. These compounds are known for their antibacterial, antifungal, and antioxidant properties. The presence of those bioactive compounds make Conyza sumatrensis a promising natural source of antibacterial agents. By exploring this underutilized plant, our project transforms a readily available natural research into a functional hygiene product with real health benefits.
Compared to conventional soap, paper soap provides improved hygiene because its seed is used only once, reduce the risk of cross-contamination. In addition, paper soap reduces packaging waste and can be product with minimal environmental impact, especially when natural ingredients are used. Concept of paper soap. Paper soap is a thin, lightweight, and easy to use form of soap that dissolves instantly when it comes into contact with water. Antibacterial test on Staphylococcus aureus. In our antibacterial testing use this diffusion method, we observe an inhibition zone measuring 23.72 millimeters around the paper soap disc. This demonstrates that the soap is strongly effective against Staphylococcus aureus. The antibacterial activity is attributed to the phytochemical compound with the Conyza sumatrensis extract, which can disrupt bacterial cell walls and inhibit the growth of microbial colonies. This result confirms that incorporating plant-based extract into hygiene product is not only possible but also powerful in reducing harmful bacteria on the skin. pH test of the soap. We also evaluated the pH of the soap to ensure its safety for human skin. The measured pH was 6.8, which falls within the ideal range for topical products. Maintenance an appropriate pH is essential because it helps preserve the skin's natural barriers, prevents irritation, and maintains moisture levels. These results show that our formulation is gentle and suitable even for sensitive skin.
Formulation process. To prevent the blade extract, 16 grams of jelantir leaves were blended with 40 milliliters of water. The milk was filtered to obtain a concentrated extract. Meanwhile, polyvinyl alcohol or PVA was dissolved in hot water at 80 near Celsius. PVA acts as the primary flame forming agent, proving the thin and flexible texture characteristic of paper soap. In the second step, hydroxypropyl methyl cellulose or HBMC was applied to cold water and left to hydrate. HBMC contributes to the smooth, dissolvable texture of the soup. After both solutions were ready, the cold PVA mix was dyed into the HBMC and gently stirred. We then add glycerin with function as another moisturization. EDTI with improved stability, SLS a surfactant for effective cleansing, and 20 ml of Nisa sumatrensis extra. These ingredients were mixed until a homogeneous liquid film was formed. The final mixture was poured into a sterile petri dish. Depending of laboratory condition, the flame can be dried using an oven or simply dried at room temperature. Once dried completely, the flame was peeled off and cut into thin, uniform set. The sides are the final papers of production ready for packing and testing. This product includes several innovation aspects. First, it uses a natural, non-chemical extraction approach, making it safer and more environmentally friendly. Second, the low-cost formulation means that this product can be reproduced easily by micro, small, and medium enterprise. Third, the innovation transforms a commonly overlooked wood plant into a functional hygiene solution. Finally, the product is designed not only as antibacterial soap, but also as a potential anti-itch solution based on traditional plant benefit. The final product offers multiple advantages. It is versatile, easy to carry, and dissolves completely without resin. It contains natural antibacterial components that help reduce harmful microbes. Glycerin provides moisturizing properties, ensuring the skin remains soft after washing. This soap with a natural pleasant aroma and record low production costs, making it scalable for community-based or commercial production.
We also collected feedback from users who tested the product. Most respondents reported that the soap did not irritate the skin and left their hand feeling soft. They also appreciated the smooth foam and the attractive color of the soap sheets. Some users noted that it relieved milk itching, supporting the potential anti-itch benefit of the extracts. In addition, respondents highlighted the convenience of carrying paper soap during travel or daily activities.
Conclusion. In conclusion, Conyza sumatrensis paper soap has promising potential as a natural hygiene solution, particularly for preventing skin infection caused by Staphylococcus aureus. As bacterial resistance continues to rise, preventive approaches such as regular hand washing, use excrettable antibacterial products are increasingly important. This innovation provides a low-cost, effective, and environmentally friendly alternative to conventional hygiene products. It might serve as an early barrier against bacterial colonization before infection become more severe. The paper soap is easy to use. Simply take one seed, we eat under running water, rub gently until it produces foam, and wash your hands as usually. Because its seed is used only once, the hygiene level is greatly improved compared to shared soap.
The final slide presents the scientists reference through supporting our research. This includes students on the antibacterial properties of Conyza sumatrensis, global skin disease studies, and laboratory standard used to condition or test.
That's all.
Thank you.